Oh, what a failure. What a failure, what a failure. I know you hear me now. I know. Can we start this over again? I'm waiting till the chat catches up to realize that my audio has come back on. I haven't done this in such a long time. I've become slightly more professional in my live streaming. But, I went to go. Now I hear myself even coming out of here, this computer. I went to go use the facilities, which is something I like to do right before I start live streaming. And when I do that, even though I'm not streaming, I'm actually not even recording, so I'm gonna hit start recording, or recording to disk, I like to just mute my microphone, just in case, I don't want anything happen by accident, I don't want to confess to some crime in the bathroom by accident. And then I came back and I started and I forgot to turn the microphone back on. Anyway, I was saying, go Mexico! Please give me score updates. Go Mexico! Sorry, Sweden. Sorry, Sweden. I love you, Sweden, but go Mexico! From what I understand, if Mexico wins today, Mexico would be the first World Cup team ever to win the first three games in a row. I don't know if somebody got to fact check me on that, but I think that might be correct. Yes, Jesus in the chat says, Mexico is playing, I can't watch both. Please, go and watch Mexico. First of all, this will be not nearly as interesting or exciting. And also, this you can watch later, and you can watch the Mexico game later, but you're gonna already know what's gonna happen, and I can tell you what's going to happen here. I'm going to try to code some stuff. I'm going to make lots of mistakes. I'm going to get stuck a lot. I'm going to waste a lot of time. And eventually, maybe at some point, there will be a small useful nugget of educational material that comes out. That's what's going to happen. Okay, anyway, what was I saying? Good morning. It is me, the coding train person, Schiffman thing, human being. And I have one job today. My one job today is to complete the color classifier example with TensorFlow.js. So the two things I would like from the chat, I'm going to answer your question in a second. The two things I would like from the chat, are one, score updates. So spoiler alert, I want score updates to Mexico game in the chat. So if you're watching this and you don't want to be spoiled, I don't know. Too bad, I guess. Two, if Slack comes back online, somebody let me know because I can then look at the Slack channel for the Slack chat. And actually, since I don't have, I'm gonna be looking more at the YouTube chat than I typically do. Okay, so I have to get myself organized and figure out where I last left off. So let me open up Terminal. Also, I want to say thank you to the YouTube Family and Learning team. I was able to attend something called YouTube EduCon last week. Was that last week? I also moved to a new apartment. I'm so out of sorts. I live in a sea. I'm drowning in boxes. Going away on vacation tomorrow for 2 weeks. All right, so while... Oh, no. Sweden scored? Now I can't tell if the chat is trolling me. All right, I need somebody reliable to give me the score. Not that you're not reliable. The Dark Hound, who gave me the score of why. Look, so unfortunately, the World Cup is on a lot. And let me talk about schedule. This is the only time I have right now to do a live stream this week. And I have some bad news, I suppose. If you enjoy watching these live streams, there won't be another one until the week of July 15th. I'm going to be away for 2 weeks. The good news, it's true. Okay, that's too bad. The good news is, which isn't really good news for you, presumably as a live stream viewer, but for the non-live stream viewers out there, I have a backlog of about 8 edited video tutorials that have not been published to the channel. And I'm going to make a couple more today. Mostly there's the first 7 parts of this color classifier thing, if you can believe that. That's right, 7 parts. And then that one edited challenge of doing a subscriber visualization. So those will come out, be published as public edited videos once every few days while I'm away. And I should also let you know that most likely, even when one comes out and is public, you can look in the description. If there's a link that says next video, you can go to the next video. You might see that it's unlisted, but I don't know if this is good practice, but this is the way that I approach if I have a series of like a 10-part series, instead of just putting them all 10 live online at once, I space them out every few days, but I leave the other ones there unlisted, so a viewer who really wants to watch all of them at once could do that. Okay. Oh, Germany scored. I'm not paying attention to that game. I guess that's good though. Do you go Germany? Who's Germany? I don't even know who Germany's playing. I'm just rooting for Mexico. I don't know. I'm like a huge Mexico football fan. All right. Oh, Italy scored. All right. I would like to do something with I'm a little bit of a baseball nerd. I'd like to do something with machine learning and Major League Baseball data, something that I'm thinking about if people have ideas or suggestions. There is an entire example created by the TensorFlow.js team that classifies pitches into balls, strikes, curveballs, sliders. No, not balls and strikes. That classifies, what was I saying? Classifies pitches into fastball, curveball, slider, etc., based on the pitch data. All right. Wow. We've got a good World Cup discussion. I love the international quality of this audience. I love that there's a great World Cup discussion going on in the chat. It is a wonderful break from the usual which programming language or which IDE is better than the other. So if it's one thing that the World Cup has done, it's made us forget about all of our quirky preferences for coding editors and the like. Sorry, C.R. Brown. Can't get behind that Red Sox thing. But congratulations to you on all of the recent success. Interesting tidbit, I did go to college with Theo Epstein. I didn't really know him though. I did not get a haircut, as Shubhra is mentioning in the chat, but I meant to get a haircut, but I did just use my home grooming device to trim this beard, which had gotten out of control. So no wilderness stand today. Okay, so I need to figure out where I am. And I'm going to go to the desktop. What am I in? P5 TensorFlow probably. And so one thing I really messed up, I think, is, so something I could use help with is, it's going to not be easy for you to help with this because I haven't published the videos yet, but I was trying to keep the code that is at the end of each video separate, and I erased one set of code, so I need to recreate that, which I will do myself, but if someone wants to volunteer to do that. It's the one, I think, where I was visualizing the grid of the colors. You'd have to go back to the live stream at this point. Okay, so I'm going to create color classifier 2. I'm going to run a server. I'm going to open up the browser. And open up the console and go to color classifier 2. There we go. This is where I left off. Then I need to open up, I'm going to use the Atom text editor. Happy birthday, Sham. I can't, by the way, people often ask for like shout out or will you look at this or what. It's impossible, I think, for me to catch every message, but hey, happy birthday. I care about your birthday. Hold on, let's get this going here. I don't want this YouTube Viz thing. I do want to open up on the desktop. Oh, computers are such a silly thing. So let's close this and let's go to color classifier 2. That's where I want to be. And here I am, and let's go here. Let's make this a little bit bigger. And I think I am ready to go. So it's 11:15 a.m. My goal today is to finish this example. I really want this example to be finished. I think this example is interesting enough or has enough to it that I can both publish the kind of fixed version that is the code that I'll leave with at the end of this tutorial as part of the codingtrain.com website. And then I'll also make a separate GitHub repository with this color classifier that people can submit pull requests to, like, just improve the design and interface and that sort of thing. I do have an issue where I don't have a good system for maintaining the various GitHub projects that are associated with the coding train. And so a lot of this stuff really just like lingers and languishes. And so I am really thinking about that and how to how I can like manage the community better. And so hopefully things will improve. All right. I need to find a tissue to blow my nose. Oh, and I need to deal with this other camera. So if you remember, I did something really silly and ridiculous on the previous live stream where I didn't want to erase all of this over here. So I just turned the camera so that I could write some notes about a different project here. So let me erase this that has nothing to do with the color classifier. Okay. And I'm just realizing now that I probably don't even need this. So me not erasing it was kind of pointless. But I want to turn the camera back. Uh-oh. Loose HDMI cable. Sorry about that. Okay, no green all the way to like there. Oh, loose HDMI cable. So this should be good. Does this seem like focus and you're seeing what you're seeing? Oh, actually, I don't usually have it turned all the way that way because that little smiley face that I drew was my like testing. Okay, there we go. So I think this seems good, and this is where I last left off. I know you can't read this TF1 hot thing there. All right, so that's good. Let me come back over here and let me open up the TensorFlow API reference. We're definitely going to need that. Can I raise this a little bit? Not too much, okay. My eyesight is getting worse and worse. I need a bigger computer screen. All right. So now I am here. And so I actually, one thing that I have to talk about, which I will get to, is I'm actually going to use validation data and not testing data as part of this tutorial. Here's some news. I took about 2 or 3 hours last night kind of building out the example. I'll actually just show it to you right now. Just to prepare for today, because as you know, I typically don't prepare, but I felt like I needed to sort of see how this was going to work. So if I go to shiftman.github.io, O2 color classifier, I think this is it. So this here is actually, whoops. This here is running a version of what I want to build today. So behind the scenes, it's training the model with the training data, and this is the number of epochs. I'm going to say epoch a lot. Pronounce epoch. Oh, look, YouTube. Thank you, YouTube. Epic. Okay. Okay. What about the British pronunciation? Is it different? Epic. British pronunciation. Epic. How to pronounce. Oh, let's look at Oxford dictionaries.
Epoch. 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 Epoch.
I guess you can say it either way. Dun dun dun. Okay, and yes, I could watch Peppa Pig live right now. All right. Oh, I'm logged into because I was watching the World Cup Mexico game. I logged into my daughter's the account that I have set up with YouTube Red for my daughter to watch videos, and we can see what she likes to watch here. Okay, let's move away from that. Epoch. I want to say epoch. All right. Second one is the only correct one. I so agree. Miayam Sumi. As well as the only way to say maths is maths. All right. So this is what I'm looking to do. Now look at this. So I've trained it with the data, and we should see now reddish, yellowish, greenish, bluish, sticking with bluish, purplish, pinkish, purplish. So this will work, and I've gone now for 9 epochs. I feel confident now. It's the key is saying it with confidence. All right. Does anyone remember where I last left off? Like, what was the last thing that I did? Oh no, Sweden scored again? How much time is left? Ugh, I'm bad luck for Sweden. I have to stop live streaming. I mean, bad luck for Mexico. Come on, Mexico. I mean, I think Mexico will advance anyway. Is that correct? But it'd be nice for them to win. All right. Let me see. Hold on for a second. I'm going to go somewhere that I don't want to show by accident. So here we are for a second. I just want to log into my YouTube dashboard to find a particular video. And I have to log in now as myself. Switch account. The coding train. Then I'm going to go to my Creator Studio. Videos, color classifier part 7. 7 is the last one. So this is an edited version of part 7 that has not come out yet, but I can watch it because it is private. And I'm going to do that right now.
We're still working with our data. At some point, we're going to start training a model.
Oh, should I put on the hoodie so that it matches continuity?
I've got this whole database.
I know you can't hear the audio.
And now I've converted all that stuff to tensor.
Okay, so let me see what happens at the end. Do you want to hear this audio?
Until I have this final version of this color classifier built with TensorFlow.js.
Wait. Don't leave just yet. Wait, don't leave just yet. I do want to think about memory management. And maybe I'm going to think about memory management later. And the X's and Y's I'm going to want to use in the next video. But I probably should after I make the last little tidbit here. And then I'll move on. In the next video, I'm going to start creating the architecture of the neural network model itself. And, I'm going to introduce some new concepts. Softmax and cross entropy.
Oh no! I have to talk about softmax and cross entropy. Okay. All right, that's fine. That's fine. Okay. Okay. All right. It's a good thing I watched that. All right. All right, I'm ready. Ready, everybody? Ready, Freddy? We. I think maybe I need to get into the mood a little bit. Oh, I'm tuning the wrong string. Like, why isn't it changing? I actually have left this ukulele here, and I haven't been here for a while, so I haven't had a chance to play. I need to get a second one, so I can have one here and one at home, so I can actually practice and learn some new songs. Soft max, categorical cross entropy. Those are new concepts that I need to learn. All right, here we go. Stretch, everybody stretch. Everybody get up and stretch. Stretch your hamstring muscles. Okay, here we go. Let's cycle those cameras. Yes, Warner says stick to coding. I totally agree. Don't. Okay. Hello, I am back. I have returned to finally build the architecture to take this training data, these RGB values that are matched with these one-hot encoded labels. If you don't know what I'm talking about, you should probably go back and watch the first 7 parts of this series. But I'm now going to create the neural network architecture to train a model with this data. And I'm going to continue to use TensorFlow.js, in particular, the layers API to do this. So let's review over here a bit. Let's review over here a bit where I am. All right, so we've talked about all these things. You know what's really funny? I just want to erase. I want to erase all that. I apologize. Here, sorry everybody. Go watch the go root for Mexico for a little bit. This is just too. It doesn't help me to have this here. It's like too out of my head, and so I need to erase all of it. How ridiculous am I that I was so desperately jumping through various hoops to not erase this because I thought I needed it. And now that I'm here, all I want to do is erase it. And yes, if you haven't switched to watching the World Cup, once again, you are watching a live stream of a person, quietly or not so quietly, erasing a whiteboard. The thing is, this is actually surprisingly good exercise. Okay. Whew. Somewhere. I really need a cloth so that I don't kill the earth. By the way, we have a little family World Cup pool going, and the person in the family who happens to be leading with the best picks is my 6-year-old daughter. She has made the best pick. She is like far and away running off with it. Well, it's not over yet. I can read you her teams. She does not have Mexico though, I don't think. It's like very meditative for me. I can't believe people watch this. I mean, I can. I mean, I can't, but I can. You could be watching. How's it looking to you? I should really get one of those glass boards that I could put right here and I could draw them facing you. I think we're in pretty good shape. I should have just done this before I started, but what can I say? Don't worry, I'm going to get to coding. Is it noon already? If it's noon, I'm going to be... I couldn't... My watch battery died, my Fitbit watch, and in the packing and moving, I can't find the charger. I just can't even wear it anymore. And eventually I'll find that charger. Moving is rough. I hadn't moved in over 10 years. Okay, here we go. This is... Go get your sips of tea or coffee or do some more stretching. I'm almost ready. I think I should probably just start over. Okay. All right. I think we're in good shape now. All right. Oh, you weren't even watching. I didn't even have the camera on. I didn't have the camera on me erasing the whiteboard the whole time. Oh, everything is off. Whew. Let's cycle these cameras again. Okay, sorry everybody. All right. Are you ready? Oh, it's only 11:30. Okay. Whew. Oof. Slack is still down, is that correct? All right. Oh no, Sweden scored again? I mean, I love Sweden and everything, but go Mexico! All right. Hello, I have returned once again to make a color classifier, machine learning, blah, 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 blah. Well, my first intro was much better. Okay. All right. Hold on. I think my belt isn't tight enough. My pants feel like they're falling down. Okay. Now everything's going to be right. My brain is going to work correctly. Hello, I am back. In this video, I am finally going to start to build the neural network architecture to make this color classifier. I am going to take this data over here, which is a long array of many, many RGB values normalized to a range 0 to 1, which matches with all of these one-hot encoded labels. And if you don't know what I'm talking about, then you might want to go back and watch the first 7, yes, that's right, 7 parts of this tutorial series that's getting very, very long. But this, I think, is I'm really getting to the good stuff. I don't know, maybe it was good stuff before, maybe this is bad stuff, I don't really know, but this, I'm really excited. I'm excited because now what I'm going to do, and I'm going to use TensorFlow.js, but I'm going to create the neural network architecture. So let's just remind ourselves what we have. We have a data set. Most of the first 7 videos of the series was all just about collecting and cleaning that data set. And that data set is many, many RGB values. I think I have like 5,000, which actually is kind of very, very small for a data set, but is fine for this particular demonstration. I have 5,000 RGB values. Each one is labeled with something like bluish or reddish or purplish. These were crowdsourced, but those got converted to one-hot encoded vectors, meaning if there are 9 labels, well, let's see, then I have a vector that looks like this, 1, 2, 3, 4, 5, 6, 7, that's 10, 9, and maybe this one refers to purplish. If this particular element of this array of numbers has a 1 in it. It is that one is for a particular label, this one's for another label. Okay, so that's what I have. So what I know that I need to have some kind of neural network, and the inputs have a shape of 3. There are 3 inputs, R, G, B. The outputs have a shape of 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. This is the output layer that has a shape of 9. Inputs have a shape of 3, outputs have a shape of 9, because the goal of this is once this whole thing is trained and finished, if I send in some RGB values, what I'm going to get is a bunch of numbers all between 0 and 1, and I'm going to find the one that's the highest, and those numbers are going to be the probability of this particular data point being a particular label, and I'm going to find the one that's highest, and I'm going to assign it that label. Whew, classification. We're doing classification. So now what goes in between all this? Now this is a big question, and many different scenarios might call for multiple layers, different kinds of layers. There's something called a convolutional layer, which I will get to eventually in a video someday. But I'm going to do something really simple. I'm going to have a basic dense layer, which is kind of the standard building block of neural network systems, and I'm going to give it some number of nodes. So for the sake of argument right now, let's pretend that I just gave it 4 nodes. And a dense layer, and this output is also going to be a dense layer. Dense layer means fully connected, meaning that every input is connected to every node. And then every node in the hidden layer, this dense layer, is connected to every output. Now I'm going to let your imagination draw the rest of all these connections, but so this is what I want to architect. So let's now go and architect this. Now I'm going to do this using TensorFlow.js and the Layers API. If you don't know about the Layers API, you can go and watch my 3 or 4 part series about the Layers API tutorial, but I'm going to sort of talk you through it while we're doing it here, so you don't necessarily have to watch that. Okay, so if I come back, again, this is what I built so far. I have all of the training data in tensors, and you can see the shape of it. I have 5,643 RGB values and 5,643 labels, with 9 possibilities. Okay, so the first thing that I want to do is, and I'm going to do some goofy stuff with some global variables that I might not, just to make my life kind of easier, I'm going to create a variable called model. And my model, which I'm going to create in setup at the end after I've prepared all the data, I'm going to say model equals tf.sequential. tf.sequential. So that's me creating a sequential neural network model. It's sequential because it's a feed forward. The layers go in this order. So now what I need to do is create some layers. So the first thing I want to do is make the hidden, let's make the output layer. Now we should do it in order. We have to do it in order. I'm going to make the hidden layer. Hidden equals tf layers dense. And then I put some configuration stuff. So I make a layer by calling tf.layers, and then I specify the kind of layer. This is going to be a dense layer, and then I can pass an object in as an argument, and that's where I can configure things like inputs. So I don't remember any of this. Let's go look it up. So let's go to the documentation. Let's go to tf layers, and let's go to dense. Where do we see that? Hold on. Time out for a second. Let me look at my cheat sheet, which I didn't want to do, but I'm going to totally do. TF layers dense. I got that right. So where did I miss it? I don't see. Oh, it's right there under basic. Sorry, I'm looking around for it, and it's right there in front of my face under basic. So I'm going to make a TF layers dense. I'm going to click on that, and now I'm going to see these are all of the things that I can pass into the configuration. So I need to specify the number of units. The number of units is like the number of nodes, and I made up 4 right here. Maybe let's try 16. Maybe we want to have some more than 4. Whatever, we can make up anything we want. So I'm going to now say units 16. One thing that I know I need is an activation function. Again, I can't cover everything in this video. I have other videos where I've talked about what an activation function is and how it works. But the idea is the activation function is the function that takes all the sum of all of the things passing through the network being multiplied by the weights and kind of squashes them into some range. And so there probably is a really useful, interesting discussion we could have about what would be the best activation function to use right here and right now. Maybe later we'll try some different ones. But just for simplicity, I'm going to make a bad decision and just use sigmoid, the sort of like historically original activation function of neural networks. So I'm going to use the activation function sigmoid. Let's see, what else do I want? Input dimensions. So this is something that I definitely need to do here, because remember, these inputs, this is not actually a layer. This is a 2-layer network. It looks like there's 3, but I'm just drawing it with 3 things and the inputs being, but that's not a layer. But I do need to specify that 3 things are coming in. So I need to come here and say the input dimensions is 3, because I have an RGB value. This should do me just fine for right now. So then I want to also create the output layer. Output, TF, that's going to be dense. That's going to have 9 units because they're 9 labels. Again, that's completely arbitrary. That's just how I happen to prepare my data set. Now, I don't need the input dimensions because the input dimensions can be inferred by the previous one. The input dimensions to the output are the number of units of the hidden. So I don't need that, but I do need to specify an activation function. And guess what? I am going to use a different activation function. Softmax. So I'm just going to type that in right now. I will come back and explain what softmax is in a separate video, which I think will be the next video of this series. I'm just going to push this a little bit further. Now I'm going to say model.add the hidden, and then model.add the output. So this is now me. This is now the code for exactly what I diagrammed right here. 3 inputs into a hidden layer with some number of units with some activation function into an output layer with some number of units and an activation function. All right, time out for a second. I just want to see, do I want to do the optimizer? Yes, I think that I do. Okay. Okay, so we have now built the model. Here's the thing. The next thing that I need to do, and I'm going to do this in the next video, what I need to do is create an optimizer. So let's just put this in comments. Create an optimizer. And I need an optimization function, which typically in the past I've used mean squared error. But I'm going to use something called categorical cross entropy. I don't know what that I don't know why. It sounds really scary, but it's not. And I also can't spell it. So I'm going to create the optimizer, then I'm going to compile the model, and then I'm going to train the model. These are the next steps that I need to do. This is the architecture for the model. People are telling me I have an error. Oh yeah, I have some extra comma here. So this is what I'm going to do in the next video. And so what I need to do in the next video, this is like just a few lines of code, but I need to, I can just add them, but I would like to try to understand a bit more about why I have softmax here instead of sigmoid or relu or any of the other activation functions, and why I might choose categorical cross entropy instead of mean squared error, which is, if you have happened to watch my XOR TensorFlow.js coding challenge or some of my other layers tutorials, I always just use mean squared error. So that's what's coming in the next video. I'm going to create the optimizer, I'm going to compile the model, and I'm going to talk about softmax and categorical cross entropy. Oh, wait. Let's actually run this and see if there's any syntax errors. No. Okay. And if I just say, if I look in the console here at model, we can see there it is. This is the object, and it's got all this stuff in it. All right. See you in the next video. Okay. Now is the moment where people can ask some questions or offer some comments before I move on to the next. So I need to open up a Wikipedia page for softmax. And then, why does everybody make everything look so insanely insane? And then categorical cross entropy. One thing I want to know is what's the difference between categorical cross entropy and, because I think if I go to loss functions here, it's actually not here. So this is, I don't know if, this is a bit of a point of confusion for me. The loss function here is written as softmax cross entropy, but I know for a fact, because I was building this example last night, I'm looking at the chat. It's so hard to follow the chat without the Slack channel. So here's something I would love. So this is what I'm building. I have it in here already. Right? So this is what I did. I used categorical cross entropy because this I have found in, this is what I found in examples of TensorFlow.js. However, as the loss function. And then, but however, if I go here and look at the API docs, it says softmax cross entropy. Are those the same thing? No. Metrics. Oh, it's a oh. Interesting. It's here under metrics. Huh. I'm looking at the chat. I guess I'm gonna just kind of gloss over this right now. And this should be a lowercase e, by the way. I mean, I'll leave that there since, all right. Oh, I also messed up, which is that the optimizer, oh, I totally misspoke at the end of the last video. Oh yeah, okay. Thank you for the battery. The battery notes. I only have one plug today, so let me plug this in. So the first thing I totally messed up, the optimization function is stochastic gradient descent or adaptive something. The loss function is mean squared error, or in this case, I'm going to use categorical cross entropy instead. Okay, so that I messed up. Okay, all right, so I got to just move on, I guess. Let me cycle the camera. Okay. The chat has more entropy than the program itself. All right, I am going to move on. And let's look at why is the word entropy used? That's what I would like to understand. It's between two probability distributions, P and Q, over the same underlying set of events, measures the average number of bits needed to identify an event drawn from the set coding scheme. So basically, let me see if I get this right before I put it in the tutorial. Where did I put my marker? Where is that marker? Oh, here it is. So this output layer, ultimately, with softmax, gives us a probability distribution. And we could absolutely look at the correct distribution, right? The thing that we're training against, the calculating an error, is this, right? The one hot encoded vector. So we could use mean squared error. It would give us a loss. But cross entropy is a formula for looking at the difference between this output vector and this vector if we're considering these probabilities, because it uses a different formula to compute the loss, but the error between two probability distributions. It's optimized for that. And in particular, and it's linked to using cross entropy with softmax, because softmax is an activation function that generates a probability distribution from any just vector of numbers. That seem about right without going into the actual maths, the formulas for these two things. Although I might describe the formula for softmax. I think that's worth doing because it's much simpler than it looks like on Wikipedia. But does that seem like a fairly accurate explanation before I get into the next video? Oh, Korea scored. That's exciting. I'm going to have to wait a minute for people to catch up to me. I'm going to look at the formula here. So it's just the sum of probability P times log of probability Q. That's pretty simple, actually. H of P is the entropy of P. The cross entropy for distributions P and Q is this. And for discrete P and Q, that's what we have here. It means this. Okay. I'm not going to get into the maths of cross entropy. Is Slack still? Somehow everyone's just talking about Mac versus Windows. Slack. I'm just going to quit Slack because it's causing my computer to freeze up here. How am I doing time-wise? It's only noon. Okay, I think we're pretty good. What's a nice definition of entropy? Like, lack of order or predictability. All right, I'm not seeing anyone complaining about my explanation. In fact, no one's even there's like a completely separate discussion going on in the chat that has nothing to do with what I'm talking about. So I'm just going to assume that I'm going to move forward. How much time is left in the Mexico game? Okay, thanks, Dan. I'll take that as a yes. All right. Oh, Korea is beating Germany. I didn't realize Korea and Germany were playing. Entropy is a mathematical way to determine how, thank you Jodo Micron, who writes, entropy is a mathematical way to determine how chaotic something is. In this case, it's a way to measure how different two tensors are to one another. That is a great way of explaining it. So let me say that again in my own words. So in other words, entropy as a measurement of how chaotic something is. So cross entropy is basically looking at this probability distribution that the neural network generated and the sort of known correct one, and what's the sort of chaos that exists in between those two. What's the cross entropy, the error between those two probability distributions? How, if we are using them as if we're generating an outcome, Like, how chaotic is that outcome going to be? Well, with the one hot encoded vector, it won't be chaotic at all. It'll always be just the one thing because it's 100% this label. But with this, what's the cross entropy there? I think that's a good way of describing it. All right. Let's move on. All right. Okay, I can't look at the chat now. Okay. Okay, I am back. I am back to create an optimizer and a loss function and compile my model for this color classifier. Now here's the thing. At the end of the previous video, I was talking about, oh, I want to use, I'm going to use the thing called softmax, and I want to create an optimizer. I want to use mean squared error. I want to use categorical cross entropy instead of mean squared error. Boy, did I really kind of botch that. The optimization function I want to use, this is something I'm choosing from. For example, what I'm going to use is stochastic gradient descent. This is the optimization function that, wait, hold on. Let me start this over. I need to get my head straight here. Okay. All right, here we go. I'm actually going to, I think while I'm recording, I don't really need this laptop even open because I have there's no Slack channel and I have the YouTube chat over here. Although actually, I just realized it could be useful because I do have my pre-made code, which I rarely do in advance. Sorry, I do have that over here, so I think that would be useful to have available to me. How, and then this needs to go down a little bit. Okay. All right, I'm back in part 471 of building a color classifier. Now, what am I going to do here? In the previous video, I created the architecture of my model. A hidden layer, an output layer, a TensorFlow.js sequential model. 2 dense layers, activation functions, units, etc. Now, at the end of the last video, I said, oh, the next thing I need to do is define an optimization function and then compile the model. Well, I really botched that because there's 3 things that I need to do. Optimization function, loss function, and compile the model. And so I kind of conflated optimization and loss. I'm optimizing against the loss, but the optimizer that I want to make is, I can use const, I guess, here. Again, I'm very inconsistent about when I'm using const versus let. Maybe I'll go back and clean up that code at some point. I'm going to say, I can get it from tf.train, stochastic gradient descent, and I can create a learning rate, which I'm going to say is like 0.2. So one thing I need to do is create an optimization function, right? There are different options, and we can try other options. Stochastic gradient descent is the one that I basically used in almost all of my examples and covered in detail in my how to build a neural network from scratch sort of series. And the idea of gradient descent is walking along, trying to go down the graph of the loss function to minimize that loss. So what is the loss function that I want? Well, if I'm going to say model.compile, I believe this is a function that I'm going to write with a configuration option. And one of the things when I compile the model, I need to specify optimizer. Now this is very awkward that I just called this up here, but that's fine. And then the other thing that I need to specify is a loss function, mean squared error. So this is typically what I have done in previous examples, if you look at my XOR coding challenge. But this is now going to change, and the reason is because I am using an activation function called softmax. So let's talk about what softmax is. Softmax, question mark. Okay, so remember, the output that we want from the neural network is a probability distribution. right? What's an example of what an output might look like? It might look like this. There's 9 values, 0.1, 0.1, 0.2, 0, 0, 0, 0.7, 0, 0, right? Whoa, my math is off. 0.6, right? These all add up to 100%. This is the idea. What this is saying is this particular RGB color has a 60% chance of being, bluish, if that's the particular label that matches with 0, 1, 2, 3, 4, 5, index number 6. A 10% chance of being reddish, a 10% chance of being purplish, and a 2% chance of being greenish. This is what we want. Now the training data is encoded like this, and maybe we can actually look at it right next to it. Maybe this is what the training data looks like. 0, 0, 1, 0, 0, 0, 0, 0, 0. A one-hot encoded vector, because actually the correct label for that color is greenish. So I need a loss function. Well, I haven't got, sorry. I'm going, cross entropy and softmax are linked together. They're used together. So that's why I just can't remember which one I'm explaining. But I need a loss function to give me the error between this probability distribution and this probability distribution. But I need my neural network to generate a probability distribution in the first place. Activation function, as you might recall, is something that squashes any number into some range. So one way of thinking about it, the sigmoid function, if we were to graph that, sigmoid function, it looks like, oh boy, I can never do this. Something like this. Oh boy, that's a terrible graph of it. You can look it up on Wikipedia, something more like this, right? And the top is 1, the bottom is 0. So any number given to sigmoid results in a number between 0 and 1. Softmax is an activation function that not only squashes the values that are coming into these outputs between 0 and 1, but guarantees that they all add up to 1. Now you might say to yourself, that's easy. That's very easy to do. We do this all the time with normalizing data. I could just take all of the outputs, add them all up, and then divide each one by the sum of the total, right? Because let's say somewhere I have these numbers, 2, 2, 1, 5, right? I can add all these up, and they're going to add up. Oh, look at that. They added up to 10. Let me divide by 10. I have 0.2, 0.2, 0.1, 0.5. So this, we could do this sort of like divided by the sum as our activation function, but this is not going to give us an accurate probability distribution that we want for this scenario. And softmax is another way of doing the same thing with more, that sort of expands the difference. This one makes this one much more likely, expands the difference between these different values. So the way that softmax works is we actually do the following. You know that, hold on, I gotta find an eraser. You know that natural number e for natural log? 2.7 something, I think. Well, what if I said and took e squared, e to the 1 power, e to the 5th power? What if I took all of these? What if I took all of these and then added them all up and made that, I'll call that the e sum, and then just took each one of these values and divided by e sum? That is softmax in a nutshell. You know what I think I'm going to do? I'm going to have a tangent video that you can go and watch now, where I'm actually going to write the code for the softmax function, which I think will explain it better. I don't think it's worth doing that in this video, but I'm going to do that in a separate video. So look for that in the link. Look for a link to that in this video's description. Just to be sure that I'm right about this, we can now go here. And this makes it look like, oh my God, this is like the craziest, scariest thing in the world. But you can see it right here. The softmax function for a vector of values z means take every value, e to that z index j power, divide it by the sum of all of those values. And so that, and you can see here, the probability theory, the output of the softmax function can be used to represent a categorical distribution, a probability distribution over k different possible outcomes. Time out for a second. So what I want to do is, you know what, I'm going to do that in a different video. Okay, yeah. Okay. 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 All right, so again, in a separate video, I'm going to write the code for softmax, and actually it's right there in TensorFlow.js, also has functions for doing it. And I'm going to compare what those outcomes look like versus just summing and dividing. But I'm going to move on and say, so if I've established that softmax is what I'm using as the activation function for the last layer, the output layer, the question then becomes, what loss function should I use? How do I calculate the error between the target outputs with the training data and what the model generated during the training process? So again, mean squared error would work here, but I am going to change that. Oops. Stupid sound effect. To categorical cross entropy. Why am I using that? So first of all, what is entropy? Entropy is a term that refers to like the chaos associated with a system. So you can think of a probability distribution as like being very chaotic or more or less chaotic. So what the cross entropy function is a loss function designed to compare two probability distributions and look at how much chaos there is in between them. The cross entropy between them. And the math of it is, mean squared error is like subtract, take this one minus this one, and then do like the square root, or square it, then do the square root, or maybe don't do the square root, then add them all together. Mean squared error, right? I've talked about that. You can look it up. It's a pretty simple mathematical function. Cross entropy, if we look at it, we could build this. I could build this in a separate video, which might be worth doing as well. Is really just if I have two probability distributions P and Q, I'm looking at the negative the sum of one probability distribution times the log of the other probability distribution. So again, you can research what cross entropy, how the math behind it works in more detail, and maybe I'll do a video about that for those who are interested. But at the moment, the important thing to where am I? Over here. The important thing to realize is that softmax is an activation function for generating a probability distribution, and cross entropy is a loss function that works well for comparing two probability distributions. So for a classification problem, those are the two things we want to use. Pause. Wait. If it's a binary classifier, it's better if Dan used binary cross entropy. Yeah. That's a good point. Okay. And in the chat, someone just mentioned that if it was a binary classifier, there's only two possible outcomes, hot dog or not hot dog, I think is the classic example now, then I would use binary cross entropy. So again, there is no be-all, end-all for the loss function you choose. I'm just showing you one scenario with the idea of unlocking your mind to think about, well, let me research all these other loss functions and why would I use one versus the other and what's available as part that I get for free as part of TensorFlow.js. Okay, so we've done that. Oh, I think I'm done with this video. Let me just kind of like run this code. Oh wait, we got it. Unknown loss. Oh hey, I think this is lowercase e. Okay, there we go. So now we're done. What is the next step? What am I going to do in the next video? It is now time for me to call model.fit. Model.fit is actually the function I will call with the x's and the y's that I've prepared in a previous video to train the model. Right? I really only got 2 steps left, and I'm sure there's going to be lots of other stuff that I'm forgetting about right now. I want to train the model. Then I want to use the model to give me a label for a new color that the user is going to specify. Okay? So in the next video, I'm going to actually add model.fit. See you then. Please talk about the difference between stochastic gradient descent and gradient descent. That's a good question. I should talk about that somewhere. Maybe I think I need to do like little aside videos. Let me see if I can answer this now and somebody can tell me if I'm correct. Stochastic gradient, I always forget which one's which, but stochastic gradient descent is the one where you sum a whole bunch of like loss function values and then compute the gradients, as opposed to computing the gradients for each data point one at a time. It has to do with when do you tune the model, when do you tune the weights. Like, here's a data point, what's the error? Here's a data point, what's the error? Here's a data point, what's the error? Do I do that 100 times, then tune some weights? Or do I tune some weights in between each data point? I can never remember which one's which. Stochastic means doing it in batches. Okay. There we go. All right, how am I on time? 12:10, that's pretty good. I kind of want to be done by 1 if I can. So we're going to do model.fit in the next video. All right. Okay. All right. Whoa, binary cross-entropy is for multi-label classifications, whereas categorical cross-entropy is for multi-class classification, where each example belongs to a single class. Oh. Oh, I messed up. So I totally misexplained that. Mathieu, I wonder if you can cut out the thing where I mentioned binary cross-entropy. Oh, people are asking, I guess, about this is a Google Summer of Code t-shirt. Yes, so I think since 2011, I missed 1 year. I have done, I'm been the org administrator and sometimes mentor for the Processing Foundation, Google Summer of Code. So Mathieu, let's figure out what to do about that binary cross-entropy thing. I guess it's not the worst thing that I mentioned in there, that I got it slightly wrong. By the way, this is something that came up in that YouTube conference that I went to. Like, there's no way to correct a video. There used to be those annotations that you could add. There's no way to correct a video without, once it's been published, without like just removing it and uploading a whole new video. Binary cross-entropy. Look at this. Anyway, I'm not going to worry about it too much. Okay, so let me cycle the cameras. Okay, Slack come back. Oh, I'm out of water. I might need to go get some water. All right. Okay. Okay, at the chat. All right. It's time. It's time to fit our model. Here we go. So far, hopefully you've watched all the previous parts of this series. If you haven't, that's fine too. But what I have so far is I've prepared my data set, loaded it from a JSON file, I've turned everything into tensors, and then I created a model, TF, using TensorFlow.js, a TF sequential model, which is designed to receive RGB inputs and output a probability distribution for color labels. And again, this is somewhat of a trivial scenario, but I'm classifying data. Simple data with just 3 values all between 0, 1, and 9 possible categories or labels. Okay, so that's what I've done so far. So now that I have this is actually like, in some ways this video is going to be over in like 2 seconds. Not really. All I need to do is call model.fit. So model.fit, now what do I need to pass to model.fit? Well, the idea of model.fit is that I'm saying, hey, here's the training data. Here are all the inputs, and their associated target outputs, which I have called x's and y's. Now, I think I'm going to get an error right now. Let me just actually run this, and I'm going to, whoops, let me run this and see if I get the error that I'm expecting. Yeah, so look at this. Oh, okay, so a couple things. Welcome to your life doing machine learning. Shape mismatching. I didn't even expect this error, so I have to think about this one. Error when checking input. Expected dense input to have shape 3, but got array with shape 5,643. So I guess, right, I'm sending in not just 3 inputs. The shape of my inputs is many. So I think if I just do, well, let me look at an example that I made previously. That's weird. I didn't have this issue. Hold on, I'm thinking about this. Where is this error coming from? Hold on, I have to think about this for a second. I know that this batching thing is always an issue. I thought I took care of that. I'm just looking at the code I wrote yesterday. But that's so weird. The code that I wrote yesterday, is there something I did to it? X's, colors, yeah. Oh, input shape. Got it. That's the difference between the code that I wrote yesterday. All right. Aha. So I made a mistake and I used input dimensions where what I really meant was input shape. Let's see if we can actually look in the documentation here. Input dim for the dense layer. What's the difference? Oh, input shape isn't actually listed here. If specified defines input shape as input dimensions inside of brackets. So actually, I think this would probably fix it. Let's try this, right? Really what I want is this. Like I'm going to have an array of batches of data, each one with 3 values in it. So I think, no, but probably what I would need to do is say 5, because I know I have this much data. Maybe I need to do this. This is actually not the way I want to do it, but let's try this. No. So weird. I know what I want I know what's going to work is this. All right, let me go redo that explanation. I have to think about this more later. I went down a little bit of a rabbit hole there that's unnecessary. All right, let's go look at the documentation and see what it says there. And I've got it pulled up already. Okay, so you can see what I specified was input dimensions. If specified defines input shape as bracket input dimensions. Oh, so actually, I don't even need those array brackets there, and that should fix it. There we go. But if I wanted to use those array brackets because I'm sending in many data points, I could actually just specify the input shape directly, and this would then have the array brackets around it. So it's a subtle distinction. I think because only input dimensions is documented, let's use that one, and let's put a 3 here. Okay, so now we've got that. I wonder why that didn't, because I didn't call fit before. Okay, so now I'm fitting the model. I don't see an error. I expected an error. So what happens when I fit the model? Well, it returns a promise. Model.fit returns a promise. If you don't know what a promise is, guess what? I have a whole set of videos about what a promise is. And I'm also going to be using eventually await and async, which I also have videos about. But right now I can just write the .then, fit returns a promise, which I can then call a function called then to where the results will be passed in. And I'm just going to say, and I'm going to use this arrow syntax, this ES6 arrow syntax, console.log results. And eventually I might want to do more with this, so I'm actually going to make it a full function. So this is what I'm saying is, once you fit the model, then log the results. Let's see what happens. Waiting, waiting. Ah, okay, great. Look at this. History, loss, and there's my loss. So it fit that model. It did one epoch and gave me a loss. Great. So done. Train the model. Here's the thing. What I want to do ultimately, so this is actually in a way done. What I want to do is, first of all, I want to train the model for more than just one epoch. So one thing that I need to do here is pass in some options. So I'm going to create a variable called options. And one thing I can specify is like epochs. I'm going to say do it for 10. And then I'm going to say, and let's just say 2 right now because it's going to take a while. So the third argument to model.fit is options. And if I go into TensorFlow.js and I look for model.fit, oh, whoops, I was right there already. We can see now these are the various options. And I'm going to be using a bunch of these. But epochs is one of them, the number of times to iterate over the training data. So let's run this now. And you know what I'm going to do? I don't think we need all of this printing stuff. So I'm going to get rid of some of the earlier printing things because I don't need to look at all of that so much. So let's run this. Whoops. Options is not defined. I spelled that wrong. I guess I still have 44 and 45 console logging stuff, which I don't need. I didn't get an error that I expected to get, which is kind of interesting. And oh, you know why? One thing that I want to do is I want to update. You know, at the time of this recording, I think the most recent version of TensorFlow.js is 0.11.7. And when I was previously recording, I was using 0.4, and I think some things have changed. So I just want to. All right, so let's let this run. It's running for 2 epochs right now. It finished, and I can look at the history, and I can see both loss. So we can see the loss went down for the second epoch. That's great. Now, let's run this over 10 epochs. And let's run this. And let's just console log results.loss, by the way. Or what was it? Is it results.history.loss? Might be that. Let's look at what it is. A history.loss. Okay? So let's do this. Whoops. I don't need that. Let's go back here. Hit refresh. And waiting. I'm going to edit out this waiting part. Or speed up. We're doing for 10 epochs. I'm gonna have a lot. I can fix this here while I'm here. This is awful. Cloaking device. Oh, it's back. Okay, great. So look at this. Over 10 epochs, the loss is going down. This is good. This is what we want to see. Now here's the thing. What's it using to calculate that loss? Huh? Oh, there's so much to discuss. I gotta get myself organized, my thoughts here. I think maybe I've done this video. I'm really breaking this into lots of small parts. And really what I've done now is call model.fit with one single option. The 2 things I need to do that are next. One is I need to figure out what's it getting that loss, like what data is it using to calculate that loss? Is it the training data? Didn't I talk about testing data and validation data? Shouldn't I be thinking about that at some point? So I've got to deal with that. Number 2 is I would like to, the point of this is I'm in a P5 sketch, and I can say function draw, background 0, and I can run this, but look at this. It just says loading up there all the while it's training. I don't have any ability to run an animation. Once it finishes, I see the canvas. I want the canvas to animate while it's training, and I want to see the loss over time. I want to have that reported back to me. So those are the 2 things that I need to do. I think I can tackle the testing and validation data thing right now, because let's do that in this video, and I'm going to add the animation stuff in the next video. So first of all, okay, So I have my data set. My data set has, I think it was 5,643 elements, data points in it. I said at the very beginning of this series, when I was preparing the data set, that a typical thing to do is divide the data, and again, this is really small for proper machine learning model, robust. I probably want to have a much larger data set, but this will actually kind of work just fine, as we'll see. I want to use probably the 80-20 rule, saying that 80% is actually the training data. So I want to just only use, really, why does it, it's because the keyboard is next to this. Just go away, sound. I want these X's and Y's to only actually be 80% of that original data. So I'm not doing that. Maybe I'll add that in at another point. That could be an exercise for you, for you as the viewer to take out 20%, or maybe because my data set is so small, just take out 10% of the data. So that's what would be used to test the model after I finish training it. But while I'm training it, while I'm actually training it and figuring out, well, how many input nodes do I want? What learning rate do I want? What are these sort of hyperparameters? What are the parameters of this system that I want to try different things? How many epochs do I want to train the model for? What batch size do I want to use? All these things are known as hyperparameters, the parameters of during the training process. If I want to be playing around with those, I need a separate data set to compute a loss that's not part of the training data, but also is not part of my testing data that I'm going to use when I'm completely done training. That's what the validation data is. The validation data is basically a test data set, but it's not your test data set when you're done and you're ready to publish your model. It's your test data set while you're doing all the training. And TensorFlow.js has a configuration option for model.fit that just says, hey, use this much as the validation data. So let's go back over here. Let's go back to the documentation. And we can see here, now I could specify the validation data, or I could just specify validation split, which is a float between 0 and 1. It's the fraction of the training data to be used as the validation data. So if I come back here, and I just add an option, validation data, and I say 0.1, I want to use 10% of my training data as the validation data. That's what's going to be used to calculate the loss, but it's not part of the training data. Now there might be an issue. I also want to make sure I have shuffle on. Shuffle is a parameter that shuffles the training data at each epoch, because you don't always want to train with the data in the same order as you're tweaking all the weights and stuff. As it's doing its training, if it's in a different order, it's going to help it out. But the validation data, I think, I looked at this before, is selected before shuffling. So it's selected from the last sample. So I might have a slight issue where if for some reason the order my data is in, there's something weird about the end of it is all one label or something, I probably want to like shuffle it myself manually, but let's not worry about that right now. But that's something definitely to be conscious of. Boy, this is so much to think about. All right, now that we've added shuffle and we've added 10% as validation data, let me now run this again and dance around. Oh, it's finished already. It's 10 epochs is not very long. So here we go. And we can see this is good. We still have a loss that's going down over 10 epochs. Maybe we can get this loss even less. Maybe we want to train for more epochs. Maybe we want a different learning rate. We need to tweak all that stuff, but I want to at least see an animation going while I'm doing that. So that's what I'm going to look at in the next video. I'm going to look at how to do an animation by also adding callbacks to these options here, okay? So, and async, I need to make this happen in an async function. That's actually, I think, gonna really help me out. Okay, I'll come back to that in the next video. Thanks for watching so far. So we train the model, I'll be back soon. Oh, shoot, I wrote the wrong thing. Wait, hold on. Mathieu, let's go back to where this finished. Let me just run this again. Unnecessarily. Shoot. And I'll fix that. Okay. So I'm going to redo the end of this tutorial. Okay, so it finished, it trained, now with the validation split. And oh, breaking news, breaking news. I'm getting information from the chat that I wrote validation data here. Interesting that it did give me an error. So if I wanted to give it specific validation data, that's what I would use, but I want to use validation split. Thank you to the chat for correcting me there. Let's try running this again. Let's give it just more epochs, a little bit more time to wait. Let's give it 50, all right? All right, so this is going to be the sped up portion where I can play the ukulele, but nobody will hear the ukulele in the edited version of this video. Why is it still printing out this one tensor, actually? Where is that? There must be, oh, labels tensor.print. All right. My validation split is 0.1. That's also known as 10%. All right, so it's back. Let's take it's back. Let's take a look at our loss function over 50 epochs. And we can see it's going way down to 0.75. You can see it's kind of stopped. It actually, we kind of accidentally might have, you can see how it kind of goes up now. We can see like it's not able to get any better. So we might not even need 50 epochs, but we might want to tune various parameters to see. But anyway, I'm not going to worry about all that right now. The point is I have now trained the model using model.fit, shuffling the data with a certain validation, saving 10% for validation. I'm not doing proper testing data yet. That would come later. And 50 epochs, okay? So in the next video, what I want to do is make it so that I can run an animation, I can graph the loss function over time, all that sort of stuff, and not have it kind of like blocking right the way it's doing right now, the animation thread. And then, of course, I also need to allow the user to specify a color and get a label for that. So those are the next 2 steps I need to do. See you in those videos. Okay, sorry, my nose is running, and my tissue box is empty. I'm out of water. I might need a little break. Let me see if I can find. Oh, you know what? Look at me here. Prepared with the Kleenex. All right. Okay. How are we doing, everybody? Wait. Crazy Teenager writes, LOL, I was watching Roblox and this on my recommended. So were you watching just like some gaming and this was like arbitrarily recommended to you and you just popped here? Welcome. Now, if you don't know about coding, what I'm doing here is probably like the most advanced stuff that I do on my channel, and you might want to go back and watch a lot of the beginner tutorials. If you're interested, you certainly don't have to. Slack is back. Okay, let me see if I can get the Slack channel going. So for those of you who might be wondering, the Slack channel is for sponsors of the YouTube channel or patrons via Patreon. It's the same thing. There should be a sponsor button you can see. I mean, nobody needs to sponsor, but only if you feel so inclined. You'll be able to watch all the content, but I use that to have a smaller community of people asking questions and discussing the stuff. I'm trying to connect right now. Okay, looks like it's coming back to me. What time is it? 12:30. I'm okay on time. This could be way worse. Josh in the chat asked, do you do tutorials on Slack bots? No, I would love to, though. Okay. Okay, let me close this thread. Okay, I am now got the Slack channel in. Welcome new sponsor, Mr. Inc. X. So I don't know if my kids are at home. They don't have school today. I'm paying for a babysitter so I can be here to do this live stream, by the way. But I set it up, my Philips Hue lights at home, they blink if someone sponsors the channel. I can't do that here because I'm in lockdown in the NYU Wi-Fi. New sponsor, Kyle. I guess I should mention the whole sponsorship thing. here and there. Thank you to those. This is very kind of you to sponsor. It does really help me allocate time to doing these videos. And Alka is thank you for thanking people. And one thing I really need to do, I need to do some maintenance in terms of like getting all the emoji stuff set up on the channel. Okay. Yeah, World Cup winner with prediction with TensorFlow.js. Okay. All right, I got to move on. Let's cycle these cameras because I got to get out of here. I'm leaving for, as I mentioned, I'm leaving for a trip tomorrow for 2 weeks. Do my kids know how to code? So my kids are 6 and 9. So I would say my younger daughter, we talk and I show her things sometimes, but she's really too young to do text-based coding, certainly. And my son, who actually he's not 9, he just turned 10. It was his birthday over the weekend. He's taking Scratch classes, and he's attended actually some P5.js workshops that I taught for 4th and 5th graders. So he does know how to do it. Unfortunately, Fortnite is a thing. It's very distracting. Anyway, someday I'm going to get our gaming channel set up. All right, sorry. Okay. All right, let's move on now to the next video. Okay. All right. Okay, this is really, let me see if I can do some, where is it? It's over here that it's like, what if I fold it? I think that's better now. The Kubo robot, that sounds interesting. Okay. Okay. I don't know about this Fortnite thing. I don't know if I should be allowing it. Okay. All right. All right. Video 7,263 of my making your own color classifier with TensorFlow.js video series. The previous video, previously on making your own color classifier with TensorFlow.js, I worked in the model.fit function. So I'm fitting the model according to my training data with these options. Now what I want to do is I want to be able to basically see an animation graphing the loss function while it's doing the training. So right now I just get a report when it's done. So there's a few steps that I want to take to do this. The first step that I want to do is I actually want to move this into a separate function. So I'm going to just write a function. I'm going to just make it a global function called train. Oh, isn't it nice? Train. And I'm going to put model.fit there. Then I'm going to call train here. So that's option one. And and I'm going to put the options here in this function. And I'm going to just go back to 2 epochs. And I'm going to run this. Oh, x's is not defined. Oh boy, I did all sorts of goofy stuff here. So let's make these global variables, x's and y's. I'm going to need to do, again, just could use some refactoring. But now it's training and 2 epochs done. We can see the loss functions. Great, but still, I don't have an animation. So what I want to do is I want this to be an asynchronous function. I want this function to be an asynchronous function, to happen and let things keep going. And guess what? I have a video series about how to do that with the keyword async. And then if I make a function async, I can use the keyword await, meaning this function will wait for model.fit to finish before it's done and it returns a promise, by the way. So I can actually take this now. I can say return await, and then I can put my then up here, right? Because it's going to return that same promise, but it will happen asynchronously. Meaning the code up here will be allowed to move on while this is happening in the background. In theory, but I've got to do more here. It's the same behavior. So why is it the same behavior? Well, I've set myself up for success, but I don't have success yet. And the reason why is that TensorFlow.js is using something called WebGL to do all of the calculations, and it's taking over basically your animation or drawing capabilities while you're fitting the model. However, TensorFlow.js comes with a function called nextFrame, which returns a promise that resolves when a request animation frame has been completed. It's simply a sugar method so that users can do the following: await tf next frame. So what I can actually do is kind of trigger the animation, letting the draw loop go. The P5.js draw loop is just using request animation frame itself by adding await tf next frame somehow in this async function. So where do I add it? So I have an idea. I'm going to add something to this called callbacks. So, and I got to spell callbacks correctly for this to work. So let's go back to look at model.fit, model.fit, and we can see that, oh, look at this. This is new as of like, unless I was looking in the wrong place, but last night when I was looking this up, it wasn't actually here. These are optional callbacks that can be called during training. For example, on train begin, on train end, on epoch begin, on epoch end, on batch begin, on batch end. So let's add on train begin, on train end, just for real quick. So I'm going to say, I'm going to have a callback on train begin. And this needs to be a function. My life's going to be easier if I just use this ES6 arrow notation. And then I'm going to have another callback called on train end. And I'm going to say training complete. So I'm going to just add these two callbacks. So these are functions that are going to be executed during the training process. Let's see if I did that right. Training start. And training complete, and I see the results. Wonderful. So what if I, in train begin, just make it a slightly longer function, which also has await tf next frame in it? What happens if I await the next frame in it? No. Oh. Huh. Do I have to say async here? Wait, where do I put that? All right. That's not what I wanted to do. Let me go back. I'm just going to look at the chat while I'm taking a little. Okay. All right. All right, nobody's discussing anything. We're talking about PHP. I don't, like, does anybody actually watch the stream, or you just come to talk about like different programming languages? And why? This is making me crazy. Okay. Batch end. All right. Training start, training complete. Okay, now let's try a different callback. Let's try on epoch end. And on epoch end takes two arguments. I'm looking over here on this computer because I have some notes there, which I don't typically do, but the documentation here doesn't actually, if we look here, it's not telling you what the arguments are for these callback functions, but I looked them up. And so the arguments are the number of epochs. So I can say num and then a log, which is like a report. So I'm going to say num and logs. And then what I can do, so what I'm going to do is I'm going to do console, I'm going to write a function here with multiple lines of code. I'm going to say console log epoch num. And then I'm going to say console log loss, a logs dot loss. So So there's a property of loss that's in that logs object. So these are the arguments to every time it finishes an epoch. So I'm going to now give it 10 epochs. Let's see what happens if I add that callback. All right. Epoch 0, epoch 1, epoch 2, epoch 3, epoch 4. Look at that. So I am now getting, I'm getting a callback for every one of those individual epochs, and we can see the loss going down. And then, of course, we see all of the loss values when we're done. But now, if I want to let it draw something, I believe I can say await tf.nextFrame. Hold on, timeout. Did I talk about what? I'm so lost into what. I'm so lost. Like, did I explain what tf.nextFrame is already? Because I went back and forth and I went down a route and then I didn't want to. I think I did explain it. Shoot, I'm confused. I'm just going to have to do my best. Mathieu, I'm sorry. Hopefully this will come together. I might end up explaining the same thing twice. Okay, if I want to draw something at the end of each epoch, if I want to allow the animation to proceed, I can go and use that function, tf.nextFrame. It's, tf.nextFrame, which allows me to sort of unlock the drawing thread and let draw update itself. So I'm going to go and I'm going to say await tf.nextFrame right here at the end of each epoch, and then this is also an async function. So this now has to be an async function as well. Is that going to allow me to do that? I think so, yes. Okay, let's try this. Ooh. Oh yeah, look, it's drawing. Now, let's actually add an animation. So let's do something like stroke 255, stroke weight 4, line frame count modulus width 0, frame count modulus width height. So I just want to draw a line that is moving across. So for example, if I don't bother calling this train function at all, we can see here I have an animation that's running. Okay, so now let's call the train function and see if that animation runs. Waiting, 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 waiting. Let's get to epoch 0. Oh, look at it. So the animation is going, but it's only able to draw once at the end of each epoch. So while it's training, if I want to let it unlock that drawing more often, maybe a different callback would work better. And in fact, something that TensorFlow.js is doing behind the scenes, and model.fit, is in the callbacks, right? It's actually batching the data. So I have 5,600 data points. It's actually running the gradient descent algorithm in batches. That's what stochastic gradient descent means. And there are also on-batch begin, on-batch ends. And I could sort of specify the batch size. I'm letting it use a default. So what I actually think that I want to use, it's going to be able to, it does a batch pretty quickly. A full epoch takes quite a bit of time. So I can actually do on-batch end. What I'm going to do here is I'm going to add one more callback on batch end. And I'm going to make this the async one. So it also has a batch number and a number of logs. So it's the like epoch end, but I'm going to put the await next frame in there. This one no longer needs to be an async function. So this should unlock the animation much more quickly because it lets it draw at the end of every batch. So let's go to this now. And we should see, yeah, look at this. So the animation is running just fine. And we should see, now it got a little glitch there when it got to the end of epoch 0. Let's see if it does that again. No, I don't know why. So the first epoch, they must have had to do some copying onto the GPU. I'm not sure why. But you can see the animation is no longer stuttering from epoch to epoch. Okay. So now we have it training the model with an animation going. Let's at least, so what I really should do is graph the loss function. And by the way, I can look at the loss function at the end of each batch, so I can get a much more quickly updated loss function. So I'm going to leave that as an exercise to the viewer. But I'm going to just, what I'm going to do is I'm going to say let loss p, and I'm going to create a paragraph element. Again, I'm not really being thoughtful about design and interface here, loss. So what I'm going to do here is it's just going to have a paragraph element that says loss in it. And what I'm going to do is, instead of logging the loss to the console, I'm going to say loss p.html. And this is using the p5.js DOM library. You could use native JavaScript or jQuery. I'm going to put this loss information into that paragraph element. So now I have an animation going. And then, as soon as I get to the end of the first epoch, I have to talk for a bit here, I see the loss function. So now I'm training and getting a report of the loss function. So for you, in the next video, what I'm going to add is inference or prediction. I'm going to allow the user with sliders to specify a color and have the label returned to me. And what I would say to you as an exercise is see what happens if you can query the loss function with the batches and graph it over time. And see that will be an exercise to you as the viewer. And I'm going to publish a GitHub repo with this finished project. So you can look for the code. This is very confusing, but you can look for the code. It'll be linked in the description in 2 different places. There'll be the code that matches exactly this video. And then there will be the code that's in a separate GitHub repo that at some point in the future people will be contributing to that will have maybe the graph in it and other kind of designy things that people have from the community have added. Okay, great. So one more video to go, I think. And then some other ancillary ones that I've forgotten about. But one more core video to this tutorial series, which is adding the prediction. And I will see you, if you're really going to watch all of these, I will see you in the next video. You can check the video's description for the next video link. Okay. Okay, so that's interesting. I should have been looking at the chat. Maybe I'll cover this in the next video. Let me try some things. So you're saying if I just say return tf next frame, I don't need the await and async thing? I like this better. And then, in fact, I can just say tf next frame. That's the callback I want to happen. Oh, that's way nicer. So I'm going to explain this at the beginning of the next video. Yeah. All right, great. Oh, David in the chat is asking, where can I find the code to the 500K subscriber map visualization? I'm way behind. I haven't published it yet. Once the video gets published as a coding challenge, then I publish the code. If you hit me up on Twitter at Schiffman, it'll be a reminder to me, and then I'll reply to you there and upload that code. Okay. You want validation loss, not training loss. Aren't I getting? Oh, do the logs have different loss? I thought the logs.loss is the validation loss. Let me look at this. Oh, that's the validation loss is different. I didn't realize that. Okay, great. Did I say video subscription? I meant to say description. Did I say subscription? Shoot. Brain is melting. I need water. I'm out of water. Does anyone mind if I go get some water? You got to stay hydrated on the coding train, as you know. Welcome, new sponsor. Thank you, FD God. My lights are blinking at home. If I could be home right now, I would see them blinking. Oh, because the lights are probably off. All right. Okay. So thank you. So the things that I need to cover at the next video are the validation loss versus the loss. Thank you for that. And interestingly enough, I think there is a problem with my validation data. I do need to shuffle it, and I just have very little data. So that's not great. And I need to talk about the simplification here of TF next frame. Okay. Yeah. Okay. All right, everyone, I'm back. Oh, never mind. Let's start over. There we go. Okay. All right. Whew. This is getting tiring, but I am back, and I have yet another video in this building your own custom color classifier with TensorFlow.js series. Now, the thing that I want to add to this video, and by the way, this line moving across is pointless. I just have it there so that I can see that the draw loop is animating, that I haven't blocked it. There's two things that I missed that are kind of important from the previous video. One is, this is actually not the validation data loss. I didn't realize this, but I'm going to change this here. I'm going to console log the full logs object. So what I'm putting onto the screen is logs.loss. Let me console log what's there. So again, we have to wait a minute for the first epoch to finish. Apologies for that. Okay, there are actually two loss values. There's the loss function computed against the training data, and there's the loss function computed against the validation data. Now, to do this properly, I really should be using the validation loss, because that's data that hasn't been done with the training. That's protecting against overfitting, having my model work really well with the training data only. The thing is, I have a very small data set, 5,000 data points. I'm just using 10% as the validation data, and the way TensorFlow.js works, it also takes that 10% from the end, and I wasn't careful about shuffling the data around. So this is something that I should come back to. I don't know, maybe this series will go on to infinity. But if I were doing this properly, I would actually want to show the validation loss here, like this, logs.validation loss. Maybe I want to show both, and maybe I want to be more thoughtful about shuffling the data first in advance. But that's not what I said I was going to do in the next video. So I'm, again, leaving that temporarily as an exercise to the viewer, or I'll come back and do it in a future video. I don't know yet. That's item number one. Item number two, thank you to Me, I Am So Me, and others in the Coding Train sponsor patron group. I made this way more complicated than it needs by trying to make this an async function in here. Actually, this does not need to be an async function if I just return tf.nextFrame. So if I just return tf.nextFrame, it's actually returning the promise and unlocking the draw loop. So that makes it simpler. And actually, what I really want to do, I could have made this so much simpler. What am I doing here? At the end of every batch, I want tf next frame to be executed. And so I actually don't need to write a wrapper function to execute tf.nextFrame. What I could just do is set that as the callback. The callback, again, if I wanted to do more with onBatchEnd, look at the loss and the logs, but really what I want is at the end of every batch to draw a new frame of animation, I can just put tf.nextFrame as the function, which is the callback there. Okay? So this is still working. That simplifies the code, makes it a little nicer to look at. I don't even really need this on begin and on end, but I'll leave those in there just so you see them. Okay, so now I'm ready for what is the purpose of this video. The purpose of this video is while I'm training the model, I could wait till I finish training the model, but I'm actually going to allow this to happen while I'm training the model. I want to be able to specify a color and see what the neural network thinks that color is. So very quickly to do this, what I'm going to do is I'm going to create a R slider, G slider, B slider. I'm going to make 3 sliders. Again, this could use a lot of improvements, and I'm going to use the P5 DOM library, create slider function. So the slider is arranged between 0 and 255. And let's start with like, does red and green make yellow? Let's start with a yellow. And so the B slider should be on 0. And then I want the background color to, and I don't know what that's doing there. I don't need this line anymore, it's distracting. I want to say R slider. Well, so I want to say let R equal R slider dot value. So I want to get the values from the sliders. I want G and I want B. Eventually I'm going to send these as inputs into the neural network, but right now I just want to be able to see that color. R, G, B. Okay, so here we go. So now we should see there are 3 sliders, and as I adjust these sliders, I can change the color. And so what I want, what I want is to be able to, and what I want is now to see the neural network's prediction down here. So how do I do that? Okay, time to use TensorFlow.js again. Woohoo! So I need to make some input data. So the input x's are tf.tensor2d and an array with RGB in it. Now, in theory, I could be running prediction with multiple RGBs, right? But I'm not, so I need an array of arrays in here. So this is my input data. Then, what do I want to do? I want to say model.predict with those x's. Feels like there's, oh, you know what? I need to normalize those, right? Because it expects to have normalized values between 0 and 1, so I need to divide each of those by 255. Then I need to call model.predict, and then look at the results. And that oh, you know what? This doesn't actually happen asynchronously. Because the data is still on the GPU. This is a confusing thing. I have to I'm going to use that data. I have to pull it out, but let's just look at the results, the pure results. So I should then be able to say results.print. Okay? So I think this is me just creating the inputs, getting the prediction, and then I should be able to see that in the console. Syntax error. Oh, I have an extra curly bracket. All right, okay, so we can see this, and this is exactly what I should be getting, right? It is a probability distribution over 9 labels. Now, whether it's giving me correct ones, who knows? But look at that. So now, how do I get the label out of there? Well, remember that what I'm looking for is I'm looking for which probability is at the highest level. Is it a 90% chance of it being yellowish and 0.01, 0.02, 0.03, 1%, 2%, 3% of being the other ones? And there actually is a function in TensorFlow.js that will pull out the index of the highest probability value. That's called argmax. Right? I could write a little for loop or some kind of function to do that, but if I look for argmax, tf.argmax returns the indices of the maximum values along an axis. So this can be quite more complex because I can have multi-dimensional data, but I actually get to do this in a really simple way. I just want to say let index equal results.argmax, and there's an axis of 1. There's a one-dimensional here. So now let me say index.print. And so let me run this, and we can see it's just giving me, is that right? Is that a coincidence? So I should get some different values. Yes, okay, so it's actually changing. So that's giving me that maximum index. So as I change, so this is my label. Here's the thing though, that's my label, but I need to convert that to one of these. So 0 means reddish, 1 means greenish, 2 means bluish, 3 means orangish. So I have this label list already. I should be able to just say, let label equal label list index. The only thing is I can't do that because this is a tensor. That's a tensor. And what I want, I need to pull that. The tensor is the numbers, the data that lives on the GPU, the WebGL fancy thing that TensorFlow.js has implemented. I need to pull that off. And normally I would pull that off with an asynchronous function. Shoot. Normally I would pull that off with an asynchronous function, but the thing is here, it's such a little tiny bit of data. I think I can pull it off synchronously and not slow down my program from running. So actually what I want to say here is data sync, and then, which is dot data would pull it off asynchronously. So let's look at, and let's say I'm going to console.log index. And let me get rid of my other console logs that I don't really want to look at right now. So, okay. So I got an array with the number in it. I pulled it off. And so then I just want to say index 0. So I only need that first value, index 0. And so there we go. That's the label number. I now have the label number. And so now I can say this. And I can say, and let's put it on a paragraph element. So let's say let label p. Let's have that be first. And so now I want to say label p equals create p. And then I should say, all the way back down here, label p.html label. Okay, ready for this? Here we go. I've started my training. Oh wait, why? This is so silly, but I want the label to be above it. I really should not be changing this right now. So let me just put it here. Okay, so here we go. It thinks that's greenish, right? Well, it hasn't gotten very far with the training. I would imagine that once we train further and the loss starts going down, it's going to recognize that as yellowish. So here, I'm going to just wait a little bit, and I'll be back in a minute. Let it train for some epochs. And I'll look at the chat. Has Schiffman opened the Slack yet? No, I still have open. Yes, I do have the Slack open. All right, I'm going to let this run for a little bit. I kind of want it to appear as yellowish. Oh, did I only do 10 epochs? I don't know. I should be console logging the epoch. There we go. Look. It's learning. All right, I'm back. So it trained over 10 epochs, and you can see now it's saying this is yellowish. Let me tune this down. That's greenish. Turn this up. That's bluish. We still got bluish. Can we get some purple? Purplish. Can we get some pink? Oh, it didn't get pink. Maybe if I add a little more brightness, now it thinks that's pink. So I have now trained the neural network to recognize, and let's see if it can get red, reddish. So we can see I can play with this all day long. This is now going to classify the color based on that particular model. So in a way, I'm done. I probably want to train it for more epochs. What are some things that I want to do? So one is I would want to be more thoughtful, get more data. I would want to be more thoughtful about the validation data. And then the other thing I would want to start doing is thinking about, well, does it actually work better? What are the hyperparameters that I can play with? For example, the hidden layer, I put 16 units in it. Well, or what happens if I use a different activation function for the hidden layer? What happens if I use more nodes or less nodes? What if I change the learning rate? What if I change the optimization function? If I use like the atom optimization function? So these are things that All these things are things that I could play with and research and think about and experiment with to try to tune the model really well. Then at some point, I also would want to save that model, right? Save it to a JSON file, so the trained model somehow, so that I could load it back in without having to run through the training process again. Maybe I'd even want a larger data set. I'd want to train it over a long time. Maybe I want to port this code to Node so I could let it train like server side without having to train in the client. There's so many possibilities. But I have now built a machine learning model with TensorFlow.js. I'm going to cry. I don't know how many videos this took that trains a model based on crowdsourced color data. And just to humor me for a second, if you remember, if I go here, this is the system, right? This system was used to allow people from the internet to click on and say, that's like pinkish, that's greenish, that's bluish, tag a whole bunch of colors, save all that data in a Firebase database, retrieve all that data, clean that data, put it into JSON file, load that JSON file here into this sketch, build a model, train the model with that data, and then pulls a new color from a slider. Oh, and I've forgotten something. Memory management. Oh, I knew there was a step that I'm missing. Estimating what category out of the fixed set of labels that color is. But I did forget something really quite important, which is memory management. Let's look at this. Memory, tf.memory.num tensors. So again, when I create tensors that are allocated to memory on the GPU to store numbers, those don't get cleaned up automatically. There's no garbage collector like in kind of regular JavaScript programming. So there are 15,485 tensors. Now one thing, and there's still even more and more and more. It's growing. This is a memory leak. So one place where I didn't clean up any of the tensors is right here. And there's an easy way I can clean this up by adding in the tf.tidy function. So what tf.tidy does is it says, just put all of this code that's inside of this function passed into tf.tidy, clean up any tensors that are made there. So this will clean up everything for me. So now let's run this again. And we're going to take a look at the tensors. There's 31, 73, and it's kind of leaking, right? Well, let's let it get all the way through 10 epochs. I'll be back in a minute when that finishes. Okay, it's taking. I should have something that's reporting the epochs. Would deer, a female deer, lay a drop of golden sun. Be your name, I call myself. Oh, it finished. Okay. Okay. So the training is complete. And we can see now, there we go. I am no longer leaking tensors. Now the thing is, did I really need 1,628 tensors? I don't think that I did. I think there is also a leak going on inside of this train function. And I think there's an issue with this. And so I might have to do a follow-up video about this, because at the moment, if I go to github.com hold on. Let's go from here to, I should have had this prepared. Where do I go? GitHub and issues. And I'm going to look for fit. Memory leak, this one. So I believe there is, at present, a memory leak in model.fit with callbacks. And you can see that's exactly what I'm doing. right? Where model.fit with callbacks. So I'm going to not worry about that particular memory leak right now. I'm going to wait for us to see if that gets corrected. By the time you're watching this, that might already be corrected, and this code might have no more memory leaks in it just by updating the version of TensorFlow.js, or I might still be missing something in here to do a memory leak. So, if you don't want any spoilers, or the follow-up videos have not been published yet, you could kind of like sort that out yourself, but I will come back at some point and talk about that. Okay, so thank you for watching. I wish you many purplish and pinkish and bluish and greenish days, all the colors of the rainbow. May they fill your days with joy. May you make your own classifier with your own data. Please share it with me. I don't know, has this helped the world, this tutorial series? I've missed so much about data and data collection and machine learning and models and algorithms, but hopefully I've done something. This is not the end, it's only the beginning. Mwah! I'll see you soon in future tutorial videos, because this playlist probably has about 300 more left in it. Okay, goodbye. All right, everybody. Okay, it is 1:15. I have done what I set out to do today, which is finish this example. I am now I'm going to leave within 15 minutes at 1:30 because I need to do that. I'm going to check some messages here because I have all these text messages. I'll make sure. Oh yeah. Oh, I just got a text message. But 11:40, somebody spoke. So my kids are at home with a babysitter. They hadn't left the house yet. At 11:40, the lights blinked. So they must have left because I did get a text message saying that the lights blinked at home. Who was that? Who sponsored? That was awesome. Okay, so that was. All right. Great. Okay, so I'm going on vacation tomorrow for 2 weeks. And so I will be online here and there. Let's see, there are currently 7 videos, edited versions of the color classifier series that have yet to be published. I could use help keeping the code, getting the code that goes with those videos online. If anyone is like coding along, or I have all this stuff in a Google Drive and wants to help with that, open an issue on codingtrain.com, GitHub/codingtrain/website. I could use help with that. But I will hopefully keep up with that. Mathieu, who also does the editing, will be uploading and editing, and these videos will get released. So the channel won't appear dead, but there won't be any live streams until the week of July 15th. I have something that I'm really trying to figure out how to do. And so I'm looking, this can be discussed in the Slack channel. I really, really, really want to get the updated version of this book out. I have a new chapter I want to write about neuroevolution. I want to fix all the mistakes, update all the code, and get a P5.js version of this book out. This summer is the time for me to do it. Now, when I get back in July, I have 2 or 3 weeks of being in New York City before I'm out of town again. And I was planning to do 2 live streams per week to keep up with the YouTube channel. But I might need to take more of a break from that so I can focus on the writing of this. So I guess I'm curious to hear from people, in terms of like keeping a YouTube channel going, you should never, what everyone says is don't stop making content, but that's not realistic. People have to go on vacation, they have to take breaks. So I don't believe in that. If the views go down, if the subscribers go down, such is life. But I do know that there are people who are funding the work that I'm doing through Patreon and the YouTube sponsorships. So what I want to do is take the temperature, how people feel about kind of that funding essentially going towards the time of working on this book, taking away some of the time of doing live streaming. So we can discuss that in the Slack channel. I'll be curious for people's thoughts. But so I don't know to what, my goal is always 4 live streams per month. That's what I'm kind of committed to. And I've actually done 5 or 6 the last few months. And so July, if I did 2, the weeks that I'm back, if I did 2 per week, I'd get to 4. In August, I could get to 4, but I'm thinking of actually doing fewer and focusing on the book. So I'll be curious for your thoughts about it. And Me, I Am So Me says that I should work on it. Live stream working on it. There is a way that I could possibly do that, but that's an interesting idea. Okay. So any questions anyone wants to ask? I also really want to get stuff in the shape for the channel, but can you have guests fill in? So that's a great suggestion, and I do want to have more guests, and I've had guests. It's the same, or it's a different kind of work to have the guests. It's not the same amount, it's not the same work, but having guests would not open up more time to work on the writing of the book. It would be a good thing for the channel and for the world, I would hope, having more guests, and I would like to do that, and I definitely am planning to do that, but that doesn't solve the problem of allocating more time to work on the book. Okay, any questions from anyone? Brick the World asks, what programming languages do you know? I would say the language that I probably know the best, even though I don't know any of them that well, is Java. I don't know, dare I say second is now JavaScript? I mean, I only started programming in JavaScript like 2 years or 3 years ago. Probably longer at this point. I'm sort of forgetting how much time has passed. I used to program in C and C++. By used to, I mean like 15 years ago. So I guess I know those languages. And I've hacked around PHP and Python and Perl as well. Next time, use Atom with Relu. It's very fast. Let's try that really quickly. So I should do I want someone to help me keep track of follow-up videos. So let me just try that real quick. If I put Atom here, and then put this here. No, is it just lowercase? Oh, look at that. Hold on a sec. I don't know that it's necessarily happening faster, but it looks like that loss went down quite a bit, and it got to yellowish very quickly. Yeah, interesting. So it's interesting, again, to try these different architectures. I'm going to put it back, because when I publish this code, all right. Is the stream over? Yes, it is over. Any classifier ideas that we can practice? Huh. Interesting question. Well, the next thing that I was planning to do, based on how long this took, I'm not so sure about it anymore, was to do image classification and use a convolutional layer. So that's something you could sort of try. Basically, everything here is the same. It's just the input data is 2-dimensional, and you'd want to add a convolutional layer, two hidden layers, one being a convolutional layer. The learning rate should be around 0.0001, probably, yeah. You could train it to use so Shubham is asking what is the Slack workspace. The Slack right now is open only to patrons or sponsors of the channel, and you will get an invitation. If you're a YouTube sponsor, I'm using both systems right now. I should probably just pick one at some point. But if you're a YouTube sponsor, I don't get your email to send you an invite automatically. So look at the community tab. There's a post there that you'll be able to see where you can find out how to submit your email. Okay. Are we going to train or get the trained models from Python? I actually do have a plan to do a video about training an LSTM model with Python, and then have that trained model come into JavaScript. Actually, there's a great post about how to do this by Paper Space. Let's see if I can find this. Paper Space LSTM Chris. No. See if I can find this. Paperspace LSTM blog. Yep, here it is. So this is a post just recently came out by Cristobal, who is one of the main maintainers and contributors to the ML5 library. And so this tutorial goes through how to work with Paperspace and train the model with your own data, and then run the model in using ML5.js, which is a higher level library on top of TensorFlow.js. So that's the other thing. There's just too much to do, because my other priority is to make a lot of video tutorials with ML5 this summer. But I'll just, go as I go. And you can see it running here. This is, so you can see it's doing predictive text based on the trained model. Okay. Well, I forgot to change Adam. I thought I didn't. Didn't I do that right here? People are telling me I forgot to change Adam, but I thought I did. And I also was being told maybe I should have a much lower learning rate for Adam. Oh yeah, reinforcement. I would love to do all the things. Reinforcement learning is actually something that I am most interested in, more so in a way than this sort of classification stuff, which is I'm also interested in, but I haven't had the time to dig into it yet. I've been doing neuroevolution, and that I have a whole set about that, which is kind of reinforcement learning style thing. Oh, is it possible to code the approximation from tau? Oh, June 28th. I don't have a Tau Day challenge. Oh, you mean it should be SGD? Oh. It should be SGD with... oh, boy. The point is to let everybody else play with this stuff. Yes, I did end the video with SGD. Oh, I see. I don't know. Okay, it's fine now, okay? I don't know what, I got it. Oh, shoot. All right. Because Tau Day is coming up, I mean, this is just, though, me, this is kind of like, where is my, there it is. If I had an idea for a really short coding challenge with tau I could do, I would. But let's at least look at the approximating pi code. What was it, 90 something? I don't think we're going to get a Tau Day challenge this summer. So what do I change here? This is the one that's approximating pi. So if I wanted this to approximate tau, I'm doing the circle probability over the total multiplied by 4. Don't I just double it? My brain is tired. Oh no, I don't. I don't. Hold on, I have to answer this for myself right now. So, the area of the circle is pi r squared. That's r. And the area of the square is 2 times r squared, which is 4r squared. So this ratio, which is r, this ratio, which I call probability, pi equals 4 times that probability. So if I wanted to do it with tau, what is the area of a circle with tau? Pi, oh no. Tau divided by 2 r squared, right? So wouldn't that be 8? Wouldn't it just be 8? Oops. Oh, the camera went off? Oh, you can't see me. Sorry, everybody. Sorry, everybody. This is what I was drawing. I was working out the approximation of pi. I can't do the tau thing now. Your record pi things needs doubling too. Oh, the learning rate has changed. Oh my God. I think I had it at 0.2. I don't remember what's in this code. X times x plus y times y. That's the distance. Well, that's is less than the radius squared that's in the circle. Oh, the record pi. No. Oh, I'm printing record pi. I see. Oh, right, of course. That's not something available? There's no mathed out tau? I have to do that? Oh, shoot. There we go. There we go. All right, I don't think this is worth me doing as a video coding challenge, just to update this one for Tau Day. I guess I could. The difference, no. You're behind, I correct that in the future, me, I am, so me. All right, so I could. All right, I don't think this is worth making into a video, but just for fun. Because I'm here and I'm leaving in why not? Oh, here, you can't see me. Let me erase all this. Okay. Okay, here we go, everybody. Maybe I can figure out a way to make this totally ridiculous, and it'll be worth. It'll be worth having done this. Close this. Oh, of course Weihart has a Tau song. Tau. Let's go here. I just want to find the digits. What do we think? Accurate? Happy Tau Day, everybody. 6.2.8. Oh, there's no point there. 6.2.8318530717958 and 4769252. Okay, welcome to a special Tau Day coding challenge. This is just me wasting time on the internet. But, you know, it's worth noting the day. I noted Pi Day, and I made a coding challenge, which was an approximating pi by using a kind of dart throwing technique. Let me close all this stuff up. We can run the example right here. The idea is I'm throwing darts into my processing canvas. And the ratio of the number of darts that land outside of the circle versus inside the circle give me the value of pi. Now, one of the comments I got so much on this video was, but you're using pi to calculate pi. Well, no, I'm not. And I want to be clear about this. I'm going to comment out all of these lines of code right here. And I'm going to say print line pi. So there we go. We can see my approximation of pi right here. Now, I am sort of using pi in the sense that probably the value of pi is used where, is the ellipse function somewhere in here? No. Wait. I thought maybe I used the ellipse function. Oh, I do. In where this ellipse function is drawn. But let me comment this out. So now I am not using the ellipse function, which probably behind the scenes is using pi. And I am only using, the reason why I'm seeing a circle is because I am calculating the distance of each point to the center and checking if it's below a certain amount. And if it's below a certain amount, it means it's inside a circle. But let's just look here. The only place where I might be calling math.pi is now commented out. I was just using that to compare. Okay? So we can see here that this is in fact not using pi, but giving me this amount. Now, why does this work? Now, I already covered this in the previous video, so you totally could just go away and do something else right now. But if you don't want to go watch the previous video, the reason why this works, just to talk about it again, is if this is a square and this is a circle, right? The area, and this is a value called r. The value of the area of the square is, each side of this square is 2r. So the area of that square is 2r squared, 2r squared, or 4r. The area of the circle, as we know, maybe from some math class, is pi r squared. So here I am using the idea of pi, but only because I know that that's the definition of the area of the circle. Now, what if I were to just throw darts at the wall and I would count how many darts landed in the circle versus how many darts landed overall? That would be the same. So the total darts divided by the circle only should be equal to, this should be 4r squared. 4r squared divided by pi r squared. So now what I want to do is solve for pi. Oh, this is hard. Okay, well, first of all, the r squared is gone. So then I could say 4 times total divided by circle total equals 1 divided by pi. Look, can I just flip those, right? So pi equals the circle total divided by 4 times the total. That seems kind of right. Maybe I got that wrong. Did I get that wrong? Because 4 times circle divided by total. Oh yeah, why is the 4 on the bottom? Why is the 4 on the top? Oh! Oops! I always get my math wrong. Okay, so guess what, everybody? All right, let's do this again. Okay, so now if I reverse these, I could say pi divided by 4 equals the circle, and this should say circle t, like the circle total divided by the total. Now I can just multiply each side by 4, and I could say 4 times circle t divided by total equals pi, or pi equals this. And if we go back to my code, we have 4 times the total number that landed in the circle times divided by the total overall. So that's there. So now, what if I want to approximate tau? Well, what is tau? Tau, by the way, is, okay, so what's the circumference of this circle? Meaning, what's the length of the arc all the way around? 2 pi r. Well, that seems like an awkward way of writing it. Why do I have to have this 2 here? What if I just had a value that instead of being pi was twice the value of pi? Then I could say the circumference is just that value times r. And that's what tau is. It's another Greek letter that I've totally botched. Let me go look up how to draw that better. So here's the Greek letter, right? Uppercase tau, lowercase tau. So I can go back. It's not so, I didn't do the worst job here. I guess, yeah, that'll be, so I could say tau r. And guess what? If r is 1, the circumference of the unit circle is tau. The circumference of the unit circle is tau? Not 2 pi. Ah! Tau. See? I don't know. People need now enjoy the comment section of this video, everybody. So here's the thing. What if I want to approximate tau? Okay. Oh boy. Oh boy. Okay. Well, the area of the circle is still 4r squared. And the area of the area of the square is still 4r squared. But the area of the circle, pi, oh no, pi divided tau. What is it with tau? Tau divided by 2? Tau divided by 2r squared. Okay. So yeah, while this is super nice, I gotta say it's tau divided by 2. So now I have the 2. Where do I want the 2? Do I want the 2 here? Or do I want the 2 there? I don't know. Tau or pi, which one? Somebody help me. But let's say I do this, then the total, 4r squared or tau divided by 2 r squared. So the r's get canceled out. This becomes an 8. And so now the value of tau, guess what? You just double it. It's just double. Tau is just double pi. Pi is just half tau. Whatever you want, just live your life. Tau and pi, just live your life with them both. 8, and then this is tau. So we now can go and revise my coding challenge. This is really, you're still watching this video apparently. I'm going to stop this, and we're going to make one of these for all of you tau lovers out there. This one goes out to all you tau lovers out there. From me to you. We're going to change this to record tau. We're going to draw that. We don't need to draw that. This is unnecessary code. I'm going to save this before I forget as approximating tau. And I'm just going to put this on the desktop of my computer. This is processing. It's Java, processing.org. Everybody always asks. Then I'm going to come down here. Oh, I don't need to do so many each frame. My formula here is now 8. Tau is 8. And I can, now what I want to do is I need to check the record tau if I get one closest, because redo the record. And then now, and this is now tau, and then, this is just math.tau and math.tau. All right, and this is record tau. Okay, we're good. I did it. I redid my coding challenge. What? What? Java.math. Where are the constants? Where are the constants? Hold on. Math.py Java. Yep. Pi. Oh, there we go. Here are the constants. E. We get E. We get pi. I don't see tau. I don't see tau. This video is over. Forget it. Done. All right, fine. I'll do it anyway. I'll do it anyway. But this is so sad. This is what I have to do. Look away, everybody. Look away. Don't look. Don't look. And now, we are now approximating tau. Happy Tau Day, everybody. See ya. Okay. There we go. Mwah. That was an extra bonus for all of you people out there on the internet watching this. Now I really got to go. It's almost 2 o'clock. So again, I'm going to be out of town for did I miss something? Hope not. I'm going to be out of town for a couple weeks, as I mentioned. All these edited versions of these videos will all become live. By the way, YouTube has this new feature, like this new premiere thing. So I kind of want to, I don't know if that's unlocked for me yet. I don't know if you've heard about this, but I'm definitely going to experiment with that. And I will see you all in the future. Okay, I'm gonna end this. I'm gonna play you out with my ridiculous thing that I always do. Goodbye. Yeah, so Mohammed is asking, you didn't use pi, but you used the formula for the circle's area. But that's okay, because I have to use that. But if I were just using it with dart throwing, I wouldn't have to. I would just have the circle drawn. I would see which ones are in and out of the circle, right, visually. Okay, goodbye, everybody. Oh, Dev, new sponsor. Thank you so much. All right, here goes.
Let's find something we want to make, some crazy idea. We'll figure out what it takes to make that dream appear. We'll try to understand now as we ride along the day now. Hop on the coding train, coding train, coding train. Come along and join us as we light it up in code, using only our imagination as the road. Whatever you're conceiving, you'll start seeing what you're believing. Just hop on